So here we go. First thing we're going to talk about is not that. That was to help someone that came in. Is how to read a graph. And Mr. Rasmussen just barely pointed out that I had that spelled wrong. I had axes, and he says it's axes, so whatever. That's plural for the things, the up and the down parts. Are we all right with that? Not things you cut down trees with. All right, so how to read a graph. First thing you need to do is look at the axes, like what is it asking me? We have temperature and we have solubility. So these graphs, I'll come back to this, don't worry. These graphs, we need to know exactly what it's asking for. And to do that, we need to know what the axes are saying. And this, honestly, if you learn nothing else in this class, being a good graph reader will help you on your ACT. Get a higher score on your ACT, go to a better college, get a better job, get a hotter wife, have better looking children who eventually support you because they'll be rich. See how important today is? Right? It's super important. What rest home do you want your grandkids to put you in? A nice one. So learn how to read graphs. All right. Then you find the point it is describing. So it will always give you some sort of like vectors that you can follow that will tell you just exactly where you need. A graph is just a grid system like a map. You'll be given coordinates and you will find the answer there, or how to find the answer there. All right, then use your problem-solving skills and your understanding of the English language to answer the questions. So like what I mean by that is if you understand like the prefix for under means below, or unsaturated, that means below saturation. Things like that, prefixes can actually help you a lot. And that's one of the valuable things you can learn in human biology, because a lot of those prefixes will apply the rest of your life in words. Or map, sorry, it's called map now. All right, so we'll follow this pattern real quick. This first question is about the red line. The second question is about sugar. So let me put a blue line on that. So this one will be the blue line. This one will be the red line. And then you don't need a line for number 3. So I'll pause this video real quick. All right, so most people will have number 1 and number 2 right. And number 3, they're going to be 90% of the way right. No pun intended, but they'll be a little bit wrong. So here we go. A solution of NaNO3, so that is my red line. All right, contains 45 grams at 50, so that's my point of reference. So at, up here, 50 degrees, so right here, it has about 45 grams, right? So we would just say, is this point under that line, on it, or above it? It's under it, right? So if it's below the line, what do we call this?
Unsaturated.
How many have that right? Raise your hands. Okay, good. 220 at 20. So there's my grid point. I go to 20. I go up to 220. Sorry, it's right here. How is that in reference to the blue line? It's above it, so it's super. Who had that one right? Raise your hands. Okay, good. And number 3 is not really supposed to be rude, but it kind of is. If you find KNO3 at 20, that's our intersection this time. KNO3 and 20. So I guess maybe I should have written this line. KNO3 is right here. At 20, you can call it really sort of whatever number you want. I'm going to say that it's 30. But is that my answer? No, because this graph is per 100 grams of water, and this is asking in bold and underline 300. So you have to do what? Times it by 3. Who had 90? Okay, those are the attention to detail humans. What, Belle? The 3 came from this. And you're not the only one. Only 3 people got it right. Please look. Let me get rid of all this crap again. This graph tells you the axis, and this is a classic ACT jerk move. It changes the axis. 1 second. It's per every 100 grams of water. But this problem asks you, all right, not 100, it's asking you how many in 300. So you find how many there are in 100, which was 30. So if it's 30 for every 100, then it would be 3 times 30 for every 300. Well, I estimated. You put 40. I'm fine with that, didn't you? So 120. Yeah, I'll be fine with whatever. Okay, well, if you got it and you tripled it, raise your hands. Okay, that's a lot better. My fault. Now, tomorrow you choose it from a multiple choice grid, and it's obvious which one it is. But it will give you the one that's not doubled and the one that is doubled. So tomorrow, what's that? Yeah, tomorrow, this is going to say 200. And it's going to be a different point on the graph, but you need to double your answer. Okay? All right. Next set of style of questions. It's still this type of graph. It says which substance on the graph decreases. You can read through those. I'll pause this again for a second and then go ahead and give this a shot. All right, number 4. This one should be very simple, I hope. Which substance on the graph shows a decrease in solubility with an increase in temperature? That would be the red one, right? Na2SO4. How many of you had that one? Okay. Number 5, if the temperature of the water is increased from 40 to 70, so don't overthink these. So we're just saying what happens to this line as we go from here to there. It increases, right? It goes up. Okay, number 6 is actually not tested at all, but I really like this question. It says, using the graph, which substance would you expect to have a negative heat of solution? If you got this one, you really do get this. That's a good sign. So what do you think?
Oh, I think it's sugar.
You think it's sugar?
Yeah.
Thank you for guessing. You are incorrect, young man. It's okay. We can still be friends.
Is it the same one?
What?
I think it's the Na2SO4.
It's the
Are you kidding me?
Na2SO4.
I was right. I copied Carly because she was right.
Carly, how did that bus feel as it ran right over you as he threw you under it?
Oh, man, you gotta be kidding me.
All right. Emily, can you explain why you think it's that one?
So if it's a negative heat of solution, that means it's exothermic. So that means it doesn't like the heat, so as the heat goes up, it doesn't dissolve.
I think Emily gets it. What do you guys think?
Yeah.
All right. So this answer, they're the same answer. Good job, Em. If it's a negative heat of solution, it means it's exothermic. Let me get me over there. And what that means is as it is heated or gets hotter, it's unhappy. So its solubility will decrease. How many of you did have that right? Raise your hands. Good. All right, that's fantastic. If you did not, that doesn't mean you're dumb.
I did have that.
I'm not pointing at anyone then. It doesn't mean you're dumb, and it's not tested. But that's a great question to see if you ultimately get this stuff. All right, we ready for the next slide? So here we go. These are closer to what the actual test questions are. All right, now, this isn't a question. I'm just trying to make sure we understand saturated, supersaturated, and unsaturated. Just a quick review. A saturated solution holds exactly the amount it can at a certain temperature. There's 3 questions that are multiple choice, and there's a couple from the graphs that we already did on your exam from this. All right? We know it is saturated when there is excess at the bottom that is undissolved. This is the red flag that you'll look for. All right? Waving in the problem. This is the red flag. When there is excess at the bottom that is undissolved, that is when it is saturated. Okay, now one of the 3 questions, it's a little bit tricky, and you're going to think it is that, but it is not. And I'll explain why. On the graph, we know it is saturated if the data point that is given is on the line representing the substance. So this little star right here, we would know that is saturated because it resides right on the line. Easy, right? So, once again, if there's excess that is at the bottom that is undissolved, then at that temperature, the solution is saturated. We good so far? Okay, next. Unsaturated means it's not holding as much as it can. We know it is saturated if they're, uh-oh, did I screw this up? That should say un right there, right? We know it is unsaturated if there is not excess on the bottom undissolved. That means I must be able to still put stuff in. Okay? So in your bowl of Cheerios, we don't know we have enough sugar until we start hearing it grind on the bottom, right? And then we know it's perfect. Yeah, thank you. All right? So, or on the graph, it's under the line. Pretty easy. So if there's not stuff at that temperature, then it is unsaturated. Next, supersaturated holds more than it can, and we know it because of a few things. But what's the big fat bold word up there? Solid. That's your red flag in this one to look for. Okay, if you see that in the problem, it's going to be supersaturated. If you wonder what these pictures are, they're red flags. All right, so we know it's supersaturated if when cooled and disturbed, it turns to a solid. Or on a graph, if the data point given is above the line representing the substance listed. And by the way, what we mean by a solid, it does not mean that like we get a crystal at the bottom. It means the entire solution turns to a solid because it was holding way, way, way more stuff than it can. Let me give you a little example here. This is not the best video. I shot this forever ago on a really low quality camera, but it'll work. Uh-oh. How do you want me to do that? No, that's the problem. All right, this is actually on the concentration part. Where is it? Notes, demos are the bottom. Supersaturated solution. Will someone in the back row hit the lights for me? All right, so right over here, I did this forever ago. This is a test tube that had water, and it had a tiny bit of water. And I heated it very hot, and I kept putting in sodium acetate, if I remember right. It might not be sodium acetate, but it's something with acetate in it, which is super soluble. And I heated it, and then I let it cool. I put in way more solid than liquid, but currently it's a liquid. So this liquid right here would be what? Super saturated. It's holding more than it can. You will notice in a second, I'm going to drop a few crystals in here. And even before I really dump them, one or two fall in and this solution starts to turn solid immediately. So I know it's pretty low quality, but the liquid is no longer a liquid. It's turned to a solid. And as it does that, it gives off a ton of heat. All right? So this right here is no longer a solution. It was a super saturated solution before I disturbed it, and it is now a solid. What's our red flag?
Solid.
The word solid. All right. We okay with that?
I have a question.
Yes.
We had to watch salt dissolve, but we can't do this as an experiment.
There's a problem with this experiment. This experiment, or demo, really, almost never works.
Oh, really?
Because as you let it cool, there's almost always an impurity or like a vibration in the air, and it just goes solid. So 1 in 10, this would work.
You're not allowed to talk when you do it then.
Well, I can talk, but it's just a pain because like you watch it cool, and all of a sudden it's doing nothing, and then it's just solid again, or it just goes solid all the moment you let it start cooling. So I did 3 or 4 of them, and I recorded them, and this is the one that worked, and I thought, I'm just going to keep this. There are cooler applications of this. We already talked, this is the same type of application for the hand warmers that you use. This is giving off all the heat that I put in to dissolve it. When it comes out of the solution, it has to give it back. So they make hand warmers that way. All right, I believe I'm here. Okay, so that's the one we're looking for on that one. Let's go ahead and go. We have these 3 questions now. If you would take a second. You really do need to think about these because they have our red flags, but they're sort of technical as well.
You're choked.
It's all right. Anyway, people on the internet, number 1 was super because we see the word solid. Good. Everyone in this room, too? You have it right. I try to make the test as easy as I can. I really do. What word we look for? Solid. That's super. I love solids. All right, next. Number 8's the one that if you miss one, you'll miss number 8, typically. If you have a cup of tea at 35, it is clear and brown in color. The tea must be cooled to 10 before sugar crystals begin to appear on the bottom of your teacup. At 35, the tea was unsaturated.
Oh, heck yeah.
Because think about the following. It becomes saturated at 10, right? Because saturation, the key to that is that we're looking for sugar crystals or something on the bottom. Correct? So if it's saturated at 10, it must be unsaturated at 35. So who has that? You got it? No? Okay. All right, then number 9, hopefully this one was easy. If you can't get more in, that's because it's holding as much as it can. And what do we call it if it holds as much as it can? Saturated. Oh boy. I'm not a left-hand writer. It's saturated.
Yeah, that actually looks pretty good.
Thank you. It looks better than normal. Fine. I'll finish it. That's hard. Yeah.
We're trying too hard.
It's because my hand's made out of metal. Making fun of me. All right. How we doing? My hand's not really made out of metal, but I have metal right here and right there. 16 screws, 2 plates, and my wrist doesn't work like most of yours. Okay, moving on.
Why'd you
I struck out one time. Instead of breaking my bat, I broke my arm. It's like, this sucks. Did people really believe that? Yeah, it was like, oh, wow. He has anger issues. I will tell you after we are done with this, because it doesn't need to be on the internet in the world.
Oh, no, it has to be on the internet.
No, it doesn't. All right. What does this mean? Okay, so find your paragraph.
Oh, shoot.
Actually,
I'm a paragraph.
Don't look at your paragraph.
Sweet.
Try and write your paragraph.
Shoot, I don't
Right
know.
here.
I don't
Try.
even know. Yeah, I don't
Paragraph
know.
of number 13 on the test says the following. It says, in a short paragraph, minimum of 4 sentences, describe the mechanisms of dissolution. Your host. As a solid dissolves in water, you must use the words solute and solvent. See how far you can get? Or just sit there, quiet with your arms folded.
I think I love this.
Okay, so our paragraph. Number 1, the process, what? Anyone remember? All right, the process is spontaneous. What did that mean? Do you remember in non-nerd speak?
Where is it on the packet?
It's right there, right where you were. The bottom of that page 6, maybe? Is that page 5 right there?
That's page 5.
Right there, right there, right there. It's there, I promise. It starts at the very bottom right there. The process of dissolving is spontaneous. It's got to be about 1.5 inches up.
Oh, yeah. That's it.
All right, so that's one sentence, right? Then the second sentence had something to do with the solute and solvent are attracted to each other, or something like that, correct? Does this seem familiar to those that were in attendance that day? I'm getting a yes from the smart kids in the front, so at least they were paying attention. All right, that doesn't mean there's dumb kids in the back, by the way. You're smart too. All right, the third sentence, or the second part, really, is that the solvent makes room for the solute, or something like that.
Wait, say that again.
The solvent moves apart to make room for the solute. Do you remember the bench example I used at the junior high? So people make room on the bench. That's that part. The solvent has to move apart so someone can sit on the bench, essentially. And then the last one is pretty easy. Once there's room made, the solute will move into the solvent. Okay, so fourth sentence, solute moves into the solvent. If you want to use a real nerd term, the final sentence could say, the solute is solvated. There you go. Yes. That's fine too. Okay. I can't tell you how many people just skip that question. I don't understand it. It's only a 30-question test, and that's worth 8 points, and they'll put IDK. Well, okay, it's actually out of 38. If you get 30 out of 38, do some math for me. You're already at like a C+. Just because you chose to skip a problem that I just told you the 4 sentences. So please don't just skip it. All right, ready to move on to the next part? 3 questions. These are on the test. They come from the very first thing we did. This is a graduated cylinder. We're going to call it A, of cold water. B has hot water. The volumes are the same. The only difference is their temperatures. See if you can answer these 3 or 4 questions. Okay, so number 10, what did we say? Which one has more? A. The answer is A. And let's remember why. It's because cold things are more dense, which means they have more particles in a milliliter, right? All right, which graduated cylinder contains the fastest moving particles? B, because a fast moving particle is a hot particle. Number 12, which GC contains the liquid with the highest density? A, that would be cold. All right, which one contains the liquid with the highest number of particles in a milliliter? That is also A. These 3 questions are all the same question pretty much. Where was it? Yeah, that one and that one. They all relate to the density of a cold thing being higher than a hot thing. All right, which one has the most room between particles? B, because it's less dense. Be all right with that one? There's a couple questions. It's like questions 12 and 13 on the exam from there. All right. Saturation equilibrium. There is one multiple choice question on saturation equilibrium, and if we don't review it real quick, you won't even think you learned that. Saturation equilibrium was the balance, where we said there's a change, but not really. And we used the example of either like in sports, how someone comes on, someone has to go off, or Channing Tatum comes to the party that I wasn't invited to, but I was there anyway. And so I leave, he comes in. Different people, more fun party, but the same amount of people, right? So I'm going to read you right now the answer word for word to this. It says, solute particles move from the solid state into the solution and back to form a solid at the same rate.
That made no sense.
I'll say it again. Solute particles move from solid into the solution and back to a solid at the same rate. It hopefully should make sense. It has science words, but it means the solute particles can come in, but then someone has to leave at the same time. Solute can dissolve if some is reforming at the bottom. And equilibrium will always be at the same rate. In volleyball, never on earth does 1 come out and 2 go in. Correct?
Part skills.
I think so. Well, part skills doesn't count. That's like, never mind, I almost said something insensitive. The world's a different place, my friends. Anyway, moving on. And finally, I feel like this horse is so dead, but we just keep on beating it. Let's do these three. All right? Try these three real quick.
Carly reminded me first.
All right. So the one with the releases the most heat is the one that's the most negative. Good job. Thank you, Jaden. Now, which one will show the greatest decrease in solubility when added to hot water? If it's added to hot, does it want to be hot? Sorry, if it is hot, does it want to be hot?
No.
No, so it's the same answers. It's the most exothermic. And then what happens to the temp of water when KClO3 is added? It is a positive value, so it will go down. Okay, that will be it. Look, all of the Guru quizzes and one more that's called a test review quiz are available to you. I would highly encourage you to do those. I would encourage you to go to the website. If there's any questions, you can watch this. There's practice tests. There's help for your homework. There's all sorts of resources